Good afternoon, ladies and gentlemen. As part of this presentation, what I intend to do is to go through the DTS provisions, and Paul's touched briefly on the provisions, but I'll go through that in a little bit more depth. And so, in terms of low-rise or timber buildings in particular, there's a growing interest from developers and builders, basically just due to the efficiencies that can be obtained in construction. So a lot of the construction practices are done in prefabricated systems. So what I'll do today is to go through and talk briefly about what the DTS provisions are for low-rise buildings, mid-rise buildings, and then I'll touch on what's been proposed for NCC 2019. So just in terms of the current provisions, and you've seen this before, straight out of the NCC, basically there's two pathways. So the performance requirements are the preliminary things that you need to achieve, or the compliance level, and the way you can achieve that is through a DTS approach or a performance solution. So under the DTS provisions, there's the pathway or the performance solution. So I'll focus on more of the DTS, and others today will talk a bit more about performance solution approaches. So in terms of the NCC 2016, so we currently have the low-rise provisions. This enables us to build 3 or 4-storey timber buildings. This has been around for a while, and I'll touch on that in a moment. Also the DTS provisions for mid-rise buildings up to that 25 metre effective height, or generally about an 8-storey building. And then beyond that 25 metre effective height is performance solution. So there are examples of buildings beyond that height, but they're all done under the performance solution approach. These terms, low-rise, mid-rise, high-rise, in this presentation, they're basically timber industry type terms. Low-rise are our buildings, 3-4 stories, and beyond that up to the 25 metre effective height. So the 4 to 8 stories we term mid-rise buildings. So they're not NCC it's not terminology within the NCC itself. So in terms of the Class 2 and 3 buildings, so they've actually been permitted since the mid-90s. So the requirements for these low-rise buildings hasn't changed. So, and Paul alluded to some of the work that was done by Professor Vaughan Beck in the 90s, which led to the code change. So since about 94, we've been able to build 3-storey timber-framed apartment buildings. And then in 2014, following a submission from the industry, we also enabled that to be extended to Class 3 buildings. So typically hotel, motel type developments. So these buildings for low-rise are all non-sprinklered. So you don't need any sprinklers for these buildings, and that's still the case today. What I thought I'd do is just, because I know we've got a range of professions in the audience, was just quickly go through some of the requirements. So for a Class 2 and 3 buildings under the low-rise DTS provisions, so you can do a 1-storey with a Type C construction. Basically, it's the least fire-resistive form of construction. Or you can do 3 stories and above for Type A, which is the most fire-resistive construction. And then you have 2 stories is a Type B, which is somewhere in between. So those forms of construction are all stipulated in the NCC. But specifically in relation to timber buildings, so for Type A construction, so the most fire resistive, so for Class 2 and 3 buildings, timber has a concession in the NCC under specification C 1.1 clause 3.10. So basically for a Class 2 or 3 building, as long as the rise in stories isn't more than 3, you can use timber framing throughout. So the whole structure can be timber framed. Any insulation you put into the structure itself, be it for thermal efficiency or acoustic provisions, needs to be non-combustible, and you need an automatic smoke alarm system throughout the building. So they're the key requirements for low-rise timber buildings for 3 stories. But we can actually go to 4 stories if the lowest storey is used for some sort of car parking, typically, application. It has to be constructed of concrete or masonry. So in effect, the ground floor would be a car park, concrete or masonry, and put 3 levels of timber above. There has to be a separation between the ground floor and the next storey above. So you need to achieve a fire resistance level of 90 at that floor ceiling level. So the floor, ground floor, floor ceiling 90, 90, 90, 3 stories of timber frame above. For the type, it's same for type B construction, except it's clause 4.3. Type B is that sort of intermediate form of construction. So you're only permitted to go to 2 stories, and that's why that first table, I put that up there. So you're not sort of saying, well, why is it only 2? That's the way the NCC is drafted. So we can only do 2 stories for type B construction. Again, timber frame throughout, non-combustible insulation and automatic smoke alarm. You can have a ground floor in a car park, but you're still only at 2 stories. So I have a car park with type B construction with a 1 story above in timber framing. So that's just a bit of the difference between the type A and type B construction. Type C is 1 level only. Paul touched on this, and I thought I'd expand a little bit. There's been a lot of discussion about using external cladding. We saw the building fire in Melbourne with the high-rise building at Lacrosse, the Lacrosse building, high-rise facade combustible that went up. In relation to low-rise buildings under the concession for timber, basically it says you need not comply with the requirements of clause C1.9A, and basically that is for any of the non-combustible material requirements. So C119A covers that. So we can still have our timber framing provided we've got that non-combustible insulation and smoke alarm system. But what clause C1.9A says, that with that concession for timber, you need not comply with the requirements for the walls, external walls, including all components incorporated in them, including the facade covering. So timber cladding on low-rise buildings has been around since the mid-90s and is still permitted under the NCC. Question?
How does polystyrene cladding?
It doesn't fit in there under that provision. So that's a concession for timber. The work that Paul alluded to that was done by Beck and Jung looked at timber cladding on the outside of buildings where they compared with existing non-combustible construction. So in terms of other forms of cladding, I have no comment to make on their use, except that the concession enables us to use timber on the outside. So just in terms of the low-rise buildings, so we can do 3-storey type A construction, 4 stories if you've got a ground floor car park in masonry or concrete. Any insulation that's installed, non-combustible, need an automatic smoke alarm system, and we can have external timber cladding, only for low-rise buildings. So in terms of the deemed to satisfy requirements, Paul alluded to this, there's a whole suite of design guides. I had a building surveyor question me about the external use of timber cladding, and so I trawled through old publications. I couldn't find the very first one, this technical guide number 2. So I couldn't find the original one that had been put out, but in 2001 we clearly stated external walls you could use weatherboard, plywood or whatever. From an industry perspective, it's always been that way. And so all the changes, and I think where I'll use the words nervousness has come about is with the high-rise building. I was down there the morning after the fire and it wasn't a very nice site, and I can understand from a fire services perspective you don't want to be fighting a fire on a 20-storey building, but a 3-storey building isn't too difficult from the outside. The walls are still fire, you achieve your fire resistance level. So you still have a fire-rated wall with a timber cladding on it.
Sorry,
yes.
This is probably a stupid question.
No stupid questions.
But for me, you'd be surprised.
No.
But when you say that those WoodSolutions design guides comply with DTS, how has that been determined, or who has said that it complies with DTS? Or
when we develop up these guides, we interact with the regulators. I won't say it as much with these earlier guides for the low rise. I didn't have a lot of exposure during that phase, but definitely with the mid-rise buildings, we gave technical drafts to the fire services, state-based regulators, the Australian Building Codes Board, and sought their input and feedback. I don't want it to sound silly, but the WoodSolutions Guide are basically viewed as the accepted practice for these types of buildings. It's the go-to document. Like I say, we engaged professionals to do these under the WoodSolutions banner, so they're very robust. We don't just release them for releasing them, but they have a lot of review and peer review of the documentation. So it's an industry document to support the DTS provisions. So the NCC provisions for mid-rise buildings, so basically up to 25 metre effective height. Basically there's another concession in the NCC for fire protected timber. So again, it's only for class 2, 3 and 5 buildings, and we can use fire protected timber wherever the NCC talks about non-combustible construction for these types of mid-rise buildings. We still have to meet the required fire resistance level. Can't be more than 25 metre effective height. The whole building has to be sprinkler protected. Any installed insulation is non-combustible, and also introduce cavity barriers, as Paul referred to, in terms of stopping that hot gases or smoke within where we've got any form of cavity. One thing I forgot to say in the low-rise discussion is that cavity barriers are not mandated for low-rise buildings, but our technical guides recommend them. So there's a difference between the NCC and the guide. So in effect, with our 235 buildings, there's a specific clause for Type A construction, and again for Type B construction. Previously, with these, the NCC only allowed concrete and masonry construction for some of these elements, such as internal load-bearing walls, firewalls and shafts. So the mid-rise provisions enable us to build all those elements out of timber construction. So Paul briefly showed this, but under the NCC, we've got, here I've called it lightweight timber framing, but there's a general provision in the NCC, which in effect picks up our traditional light frame construction with some fire protective grade linings on there. The DTS provisions refer to fire grade plasterboard as the DTS. You can use other board products, but it needs the evidence of suitability from the manufacturer to show that they can achieve those resistance to incipient spread of fire requirements. So there are two provisions. One general, which these light frame systems come under. The other one is known as massive timber. So this is, as Adam alluded to at the introduction, solid slabs of wood. So there's a requirement that we have a minimum thickness of the panel of 75 millimetres. That's the only additional requirement. So these timber systems need a fire grade plasterboard, and they also need sprinklers throughout. General systems, I won't spend a lot of time on them, but typically your traditional frame construction will fit in under that. And then we have our sprinkler systems, and typically it will be our sprinkler systems throughout. 2 layers of 30mm fire grade plasterboard on the walls, 2 layers of 16 on the ceilings to achieve the fire resistance level of 90-90-90. Now, you may not have twigged or may not have been clear, but even though we've introduced sprinklers, there's been no reduction in fire resistance level. So it still maintains a 90. Other forms of construction, fire engineers will reduce the fire resistance level because they've introduced sprinklers. We've got sprinklers and no reduction. So it adds to that strength or robustness in the systems. And the need for cavity barriers for these light frame systems to stop fire spread. That came back from discussions with the fire services, and I can understand it. They didn't want to be chasing fires up a 7-storey building. So in effect, we contain the fire. So we have cavity barriers at the junctions. So if there's a fire, if it does somehow breach into the wall, it doesn't go up 7 or 8 stories. It stays within that space, so it's contained. With the massive systems, basically because there's a lot of inherent fire resistance, so they need to be a minimum of 75mm thick. We need the fire grade plasterboard on the outside of that timber element. Still needs a sprinkler system throughout, but the NCC enables us to go down to one layer of 16mm fire grade plasterboard purely for the resistance to incipient spread of fire requirements. So the one layer of plasterboard says nothing about your FRL. All it's saying is that that bit of plasterboard will protect the timber element there for 30 minutes so that the timber element won't feel the fire for 30 minutes. But you still need the evidence of suitability or a test report from a CLT supplier or an LVL or a glue lamp supplier to say that their product tested to a 1530 Part 4 test, which is a full-scale test, will achieve a 90-minute fire resistance level with one layer of plasterboard. So at the time of drafting of the NCC changes, we didn't have a lot of CLT in the marketplace. We didn't, at that time, didn't have a manufacturer in Australia, which we do now. So it was all left to the suppliers to do their work. We had all that previous information from your CSRs, Boral, Lafarge, plasterboard manufacturers to say, here's our light frame systems, these are the fire performance. We didn't have any of that for these massive systems. But what we did know is that one layer of plasterboard would protect that timber for at least 30 minutes in the event of a fire. So in terms of the systems, and Paul's briefly touched on this, first line defences are our automatic sprinklers. They don't work 100% of the time. I think Paul in the analysis used the number of around 92% of the time. So when they don't activate, then we're reliant on the plasterboard systems. So we have full FRLs on our elements, no reduction because of sprinklers. We have cavity barriers to contain the fire, and anything we put into our wall systems is non-combustible, so we're not adding to fuel load. So Paul suggested maybe I show just a few little details. Light frame cavity barriers. NCC clearly talks about the placement of cavity barriers in terms of maximum distances. So in effect, we're trying to put these cavity barriers at floor level. Again, think containment. We don't want fire spreading. We want to keep it to that story level. The maximum vertical height between cavity barriers under the NCC is 5 metres. Maximum horizontal spacing is 10 metres to try and contain it within the spaces. So in our guides, we'll show these details and showing where these cavity barriers are required in order to achieve the requirements of the NCC. Again, I'll just make the comment, we helped draft the clauses in the NCC. That was the intention. It's in our technical guide as to the intention of all the requirements in the NCC. But we also have some other details for information that we didn't have at the time of drafting of the clause changes, and that when people start to talk about having penetrations through building elements. So in our technical guide, we will show details of openings in elements, and we'll reference a evidence of suitability report. This is a regulatory information report that shows the details and then gives you how to construct those in terms of your system, how to install those. So there'll be a detail like this. This is for a massive element. Basically what it will show is that you need to achieve the required fire resistance level for that building element. Any opening will be protected, so we'll run a plasterboard element to fully line the opening. And then anything that's put, any sort of system that's put in place there to enable a penetration to go through that, be it a bat system or pillow system or whatever, then you can utilise that from a manufacturer with their test report. So you need to have the evidence of suitability for the fire protective measure, the bat that you're going to use into that space. We provide the report that shows that as long as you do that, you can then use whatever infill system you can. So there's an assessment report. This is just a quick screen grab on the WoodSolutions website. Adam alluded to it, it's a huge website. The only way I can find things is straight on the homepage in the search box, put fire test reports, hit search, the second link will take you to this page. So we have information about, people get these questions all the time, fire hazard properties for flooring, for wall lining, ceiling linings, test reports are there. And then when we talk about fire resisting construction, we've got the assessment reports that are available there for free download from the website. So for those that are interested in the reports that are available, go there. My view is I'm trying to keep populating this as we get more information. We've done a whole lot of other fire test work that we haven't yet published, which will hopefully down the track will find its way to the website as well. So in terms of the pathways, again, Paul mentioned it, guides 37 and 38 are for mid-rise. 37 is how to build. 38 is the basis for the change. So all of Paul's fire engineering analysis is in guide 38. All the how to construct is in guide 37. But we can also go beyond the mid-rise buildings, and you'll see a couple of buildings go up here in Melbourne, not too far down the track. So we can go beyond that, but they're all performance solutions. So you need to engage your fire engineer and get in early with them and talk about your structure and talk about what you're thinking to enable that performance solution to be done. Guide 38 is a good document as well to give you some basis for some of the fire engineering analysis work. We're also in train working on another document that we've done based on some testing work that we have done but not published, which we're looking to pull. We've done a whole lot of fire test work that we're trying to pull together into a published document, which hopefully within, I'll give myself 12 months, but within 6 to 12 months, hopefully we'll have that all published. And that will be principally focused at fire engineers. So in terms of where are we going? So there was a submission that was put through again by the industry, which made its way out for public comment. Basically, this is going to be the extent of the change. So the current clause, C113, basically going to delete those words. So the effect of that would be that you could, in effect, build any building you can think of out of timber construction up to 8 stories. We don't know yet if that's gone through. I think the board of the Australian Building Codes Board meets later this month. We haven't had any technical comment from their technical committee, so we presume that technically it's sound. It's just a matter of time now, but hopefully if things go through, from the 1st of May next year, you'll be able to build 8-storey buildings under the DTS, fire protected timber. So don't think exposed, we're thinking protection as a first step. So look, I'll leave it there. I won't take up any more of your valuable time, but I'm happy to take any questions, if anyone has any further questions. No, that's fine. All right then, well, thanks very much for your time and your attention. Thank you.